Okay, so this problem, NI10, asks us to compute the probability described in exercise 5.2.13, and this is the integral that ends up in exercise 5.2.13. So now the problem also gives us a hint that a particular single variable integral is a particular value, and we're going to take advantage of that in a couple of minutes. So the first thing we need to do, though, is to rewrite this double integral as a nested integral. And conveniently, we have a rectangular domain. Well, of course, this whole section is about rectangular domains. So I can just use the theorem and just write this as the following. Like that. Rewriting a double integral over a rectangle is a nested integral. Good? So, all right, now, it is a little, this is a tricky problem, and there's a little bit of algebra here that, look, I mean, algebra is full of examples where there's little tricky little moves that you can use that don't come up very often, but when they do, it's super convenient, and you just, to be good at algebra, you have to sort of be aware of all these little slick little tricks and be on the lookout, and there's, lots of them, and each one comes up rarely, which means that altogether they come up fairly often. And that's what kind of happens here. So here's the move. It's a particular little sleight of hand. Notice that you can rewrite this as follows. Well, first let me factor out the 3 over pi. That's just in the way. Pull that outside of the integrals. It's legal, of course. And I'm going to rewrite this as e to the negative 3x squared times e to the negative 3y squared. Now, that's just an algebra fact, right? Okay, dx, dy. And let's look at this expression there. That is only y's. There's no x's anywhere in here. This inside integral that we're looking at is a dx integral. So for the purposes of this dx integral, y is a constant, which means that e to the negative 3y squared is a constant, which means I can factor that right outside of that dx integral. Now, I can't factor it outside the dy integral. Y is a variable for the dy integral. But I can rewrite this as follows. So I can do that. Cool? Okay. Next thing, let's look at this expression. That's not even a function. That's an entire integral, right? I mean, so the e to the negative 3x squared is a function of x, whatever. But we're doing an integral of that over a certain range of values. So this is just a number. It's not a variable or a constant. It's a constant because it's not a variable or a function or anything. It's just a number. So that, in being a constant, I can factor that outside of the dy integral. And what I end up with then is, still 3 over pi. Then I have this integral, negative 1 to 3 of e to the negative 3x squared dx. And then I have the rest of this stuff, which is integral from negative 1 to 3 of e to the negative 3y squared dy. I have that. And notice both of these are the integral that's given. Yeah?
So if you're taking the dx, right, and then like you just did.
Like this dx integral.
Right, and
yeah.
You have the e to the y stuff.
Uh-huh.
Then you can just completely take that out. You don't have to say e to the y, blah, blah, and then take the end derivative of that and just add it to it.
Yeah, I mean, this business here, the point is, this is an entire integral, right? There's a whole story. This integral's got to get evaluated before you can even begin to worry about evaluating this outside integral.
But I mean, like, the e to the y, so you can just pull that out.
Talking about this right here.
Right.
Now, this you cannot pull outside of this integral. The e to the negative 3y squared, you can pull that outside of the dx integral because the dx integral is on the inside. It's inside of the dy integral, which means that for the purposes of that dx integral, y is a constant. So that's right. So e to the negative 3y squared, also a constant. Does it make sense? Okay, cool. This is a weird little, tricky little, it just seems like, oh my God, it's too easy. We had nested integrals, and we just managed to sort of, slide that into a couple of totally separate integrals, neither of which is inside of the other. And there are just, situations that come up, not very often, but there's all sorts of stuff that doesn't come up very often, and this is a good kind of trick to sort of keep in mind. Now, the punchline is that each one of these integrals is exactly the integral that was given, and so each one of these is approximately 1.01625, and of course 3 over pi is some known number, and so you can compute that, approximately. You can approximate with.
Okay, so we could use our calculator there.
Yeah. There you'd want to use your calculator. Yeah, that's right. On an exam, if I gave you something like this, I probably wouldn't have put down this number. I probably would have said, this integral, it has a certain value, which for the purposes of this problem you can call k, and the answer would be, k squared times 3 pi times 3 over pi. Yeah. Right. Okay, we good on this problem? Okay, stopping.